Hello, in this lecture I will try to answer the question, is the universe infinite? The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter. At the present day, it is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang, so any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure that is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. And that is to say, it has no privileged or unique point. This assumption seems to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale, the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have positive curvature, which is like two-dimensional curvature of the surface of a sphere. Okay? That is to say, the universe closes inward and it is finite, like the sphere. And the second possibility is zero curvature, which is like a flat plane. Then the universe is not closed but infinite. And the third possibility is that the universe is with a negative curvature, which is like the curvature of the surface of a saddle. Okay, actually the curvature it opens outwards. Okay, so that is the reason that it is like a saddle. And it is a negative curvature. When the curvature is inward, is positive curvature, but when the curvature is outward, is a negative curvature, and it opens outward. Okay, so if it is like a saddle, the universe is not closed at all, and it is infinite. If the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, then the universe will be finite. Okay, like the sphere. Just as the surface of a sphere is finite. On the other hand, if the curvature of the universe is a constant of 0 or as a constant negative curvature, that is to say, the universe open outwards and never closes when it has a negative curvature. The universe would be truly infinite. Do we have any measurement of the amount of curvature that the universe has? Yes, there is the standard model of cosmology, which successfully fits all well-measured cosmological information as a parameter total omega, which is related to the curvature. If total omega, so the total omega is actually a number that defines how much the universe has the curvature. If total omega is greater than 1, then the universe is positively curved. Okay? If total omega is greater than 1, then the universe positively curved. If total omega equals exactly to 1, the universe is flat. If total omega equals to 1, then the universe is a flat plane, and it actually has zero curvature. And if the value of total omega is less than 1, the universe is negatively curved. So if total omega is less than 1, then the universe is negatively curved, and the shape of the universe is like a saddle. The best measured value is total omega equals to 1 plus minus 0.12. Total omega equals to 1 plus minus 0.12. So if total omega is greater than 1, then the curvature of the universe is positive, and it is like a shape of sphere. if total omega equals to 1 minus 0.12, that equals to 0.88, so total omega is less than 1, then the curvature of the universe is negative here. Then the universe is in the shape of a saddle, and the universe is infinite, which obviously could encompass everything from positive to 0 to negative curvature. So there is no definitive answer at this point, but the universe is consistent with having 0 curvature, because total omega is close to 1. So we really don't know if the universe is infinite at this point, but since the value is so close to flat, even if the universe is positively curved and finite, it would definitely be much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. At the moment we don't even know if it is finite or infinite. But there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.